In the last chapter, we talked about how to solve a type of equation that involved squares. Now we're going to look at the drawing part of that. When we're looking at that, we're looking at something called a quadratic function. The word quadratic comes from a Latin word quadratus, which means square. Okay, and so quadratic functions or quadratic equations, let's see if I can write that reasonably well here. Quadratic equations, okay, take a general form. They take the form f of x equals ax squared plus bx plus c. Now I want you to look really closely at this. Okay, c, b, and a are coefficients, and I want you to pay attention to where those are because we're going to use them later. This is what we call the standard form of an equation. Okay, and the standard form of an equation is the form that we generally want to try to use because it has a lot of uses that are helpful for us when we use those three different coefficients. The graphs that come from these are called parabolas. And parabolas look like this or like this. And these shapes are found when we graph those quadratic equation. Every parabola has the following components. Let's take a look at some of them. As I'm looking at them, okay, I want you to remember our standard form of our equation. Okay, I want you to remember our standard form of our equation. F of x is equal to ax squared plus bx plus c. And our standard form of our equation on our coordinate plane looks something like this, more or less. Every parabola has the following components as part of it. It has the following features. First of all, it has a vertex. And the vertex, depending on the type of parabola, is kind of this pointy bit down here at the end, right? And it's the part where if you flip it over that line, it ends up looking like the other half. To calculate the x-coordinate of the vertex, you use negative b over 2a. Remember, I said earlier, we need to make sure that we're looking carefully at these coefficients because we're going to look at them a lot. So you ask me, well, what happens if I find the vertex and I get this x-coordinate? How do I find the y-coordinate? Well, when you find the x-coordinate of the vertex, you will take it and you will substitute it in here for x, like we did when we studied functions. The axis of symmetry also has the same equation, right? And the axis of symmetry is exactly the way it sounds. It is the middle of this graph, and what it does is it splits the graph, if you draw better than I do, exactly in half. Now remember, vertical lines have an equation of x equals something. The axis of symmetry always goes through the vertex, so it has the equation x equals negative b over 2a. Okay, and so that is the actual equation for a line. All right. The other thing I want you to look at is the y-intercept. Remember, the y-intercept happens when x equals 0. Okay, when x equals 0. And so if x equals 0, then for each of the values of these coefficients that has a variable x, it becomes 0. So if I use x equals 0, and we can calculate that really quickly, f of 0 equals a times 0 squared plus b times 0 plus c, then the y-intercept is c, right? The y-intercept is c, and so the coordinate pair for that is 0, c. Now this all sounds really abstract, so let's go ahead and use an equation to do this, okay? The equation of a parent function is the function by which all other functions are built, right? You move functions around, you make them bigger or smaller based on a parent function. So let's look at this parent function. This particular parent function is f of x equals x squared. Okay, and this is the very, very original function of this quadratic function family. So I'm going to graph this the same way that I would any other kind of function that we've graphed before. But before we do that, we need to graph in a certain way, right? We need to find some values. I want to find the vertex. I want to find the axis of symmetry. And I want to find the y-intercept. Okay, remember from the last page that the vertex takes the formula x equals negative b over 2a. Now remember, our original formula, our general form of all quadratic functions looks like this. Okay, f of x equals ax squared plus bx plus c. Okay, now in this particular case, you see that there's no a and there's no c. There is a b though, right? There is a b. And so what is b here? B here is actually equal to negative 1. Okay, and 2a, I'm sorry, b here is actually 0. I was looking at the wrong coefficient here. B here is actually 0, and A is 1. Okay, so the x-coordinate of my vertex is 0. Now remember earlier we said, well, how do we find the y-coordinate? To find the y-coordinate, take this value and stick it back into the original function. All right, so I'm going to calculate down here in green so you can keep track. I'm going to calculate f of 0 is equal to 0 squared, which is equal to 0. Okay, and so I'm going to start graphing this thing. Okay, here's my vertex. And it's 0, 0. All right, now the next thing I want to find is the axis of symmetry. And remember, when we find the axis of symmetry, we're taking the equation, okay, x equals, and it has the same value as the vertex, so we know that it's 0. Now here's the thing I want you to see. This axis of symmetry happens to be right here on top of the y-axis. That's not always true, but it is today, right? For this function, and there are other functions, but for this specific function only. Okay, so in this case, if the x-axis of symmetry is 0, and then the y-intercept is c, okay, and so it's y equals c. Well, we said it equals 0, so the axis of symmetry is, or the y-intercept also happens at that same place. Now, let's give this shape this graph some shape. So this is what it looks like. In theory, if I fold it over that axis of symmetry, it'll be exactly the same on both sides. So let's make a chart, okay, to graph this. And if f of x is 0, then it's 0 there. And if it's 1, it's 1. And if it's negative 1, it's also 1. Okay, and so these 2 points are right here. And something I want you to realize is when you're graphing, pay attention to which points you're picking. Pick some on either side, right? You want to pick some on either side of the vertex so that you can make sure that you are getting the entire shape of a parabola. Okay, so now let's go back and let's look at the function. Oops. Let's look at the function in its general form. And this function in its general form tells us something. Okay, and this is something that I do want you to remember. So make sure if you're writing this down, you're writing it down. Okay, if A is positive, the parabola opens up, and the parabola has what is called a minimum. And what I mean when I say minimum is that's the smallest thing that the parabola, the smallest value it can have. Okay? The smallest value. If a is negative, then the parabola opens down. And then it has what we call a maximum. All right, so let's put this into practice and actually graph and analyze some of these quadratic functions here, okay? Now, I'm going to give you a function, okay? Let's use this particular function. I think it's one out of the book, but if not, just use this function for this part, okay? 2x squared plus 4x plus 3. The first thing I want you to do when you're graphing functions is I want you to identify each of the values of the coefficients and write them down, because this gives you the opportunity to keep track of each of those a, b, and c values. So a equals 2, b equals 4, c equals 3. Okay, so let's go ahead and do a couple of things here. Let's find the vertex. And so if I find the vertex, I'm going to use the formula x equals negative b over 2a. In this particular function, b is 4 and a is 2. So let's look at this and replace these values. X equals negative 4 over 2 times 2. And that ends up making it equal to negative 1, right? We're going to take this value, just like I did before, put it in here, and we're going to make it a y value, so I have a coordinate point. So f of negative 1 is 2 times negative 1 squared plus 4 times negative 1 plus 3. So that ends up being 2 minus 4 plus 3, which ends up being negative 2 plus 3, which is 1. So my vertex has the coordinate value negative 1, 1. Okay. Now I'm going to go ahead and use a chart to graph this thing. Okay. So I have my x, and I have my 2x squared plus 4x minus 3. My vertex, okay, my vertex is at negative 1. Oops. Yeah, that's right. My vertex is at negative 1, 1, so I already know that. And then I have 0. And at 0, I'm going to find the y-intercept, and it's 0, negative 3. Okay. And then I'm going to go ahead, and since I know that my vertex is at negative 1, I'm going to pick one on the other side, which is negative 2. And at negative 2, okay, I am looking at this value, which is 2 times, I'm actually going to have to calculate this one, 2 times negative 2 squared plus 4 times negative 2, let's add 3, plus 3, and that is equal to 2 times 4 minus 4 times negative 2, which is 3. I'm going to add 3 here at the end. Okay, and that equals 3. I did realize that I just made a mistake, so let me draw your attention here. Okay, I had miscopied the problem, and I copied it as minus 3 rather than plus. It is plus 3, so I am going to erase now this negative sign here because that's incorrect. All right. So now I have these 3 points. Let's graph it. And I know it's getting to be a lot on this page. Just hang with me here. Okay, negative 1, 1 is my vertex here. Okay, and then I have 0, 3, and I have negative 2, 3. So here's my parabola. Okay, so what I don't know, that's sloppy. I can't get the dots to connect. Couple of things I am going to ask you to find: domain and range. Remember, domain is all possible x. So in this case, x can be anything, right? I can have a fraction. I can have something that's not a fraction, but it can be any of these things. Okay. My range, though, is a little bit more challenging. Look over here, right? Nothing is happening down here, right? The lowest that this point goes is here. So I want my range to be everything that's bigger than that. So I want to write it as y greater than or equal to whatever that lowest value is. And we see over here that the value here is 1. So y is greater than or equal to 1, right? And again, because we're looking at a parabola that opens up, it has a maximum. All right, so hopefully you can graph and work through some of these problems on your own. I will see you guys tomorrow in class.